attending this parallel session. And sorry for the delay in starting up the session. Apparently there's a little bit of logistical problem in terms of the different venues in the conference. My name is Ayman Taloni. I will be the first presenter and hopefully the moderator for this session. And I thank you for attending this session as well. Our session will comprises of 4 presentations. The first one I will be presenting, and the second one will be presented by Mr. Mazen Hussein, who is the Montreal Protocol Coordinator and the head of the Ozone Unit at the Ministry of Environment in Lebanon. And he will be talking to us about the experience of Lebanon in implementing the HPMP. I'm going to talk later about what's meant by HPMP. Then Mr. Bassam Al-Assad will be giving us a wider regional perspective about how HPMP is being implemented, what are the focuses, concerns, and opportunities. And finally, we will, saving the best for the last, as they say, Mr. Samir Trabulsi, who is the chairman of the FEA chapter here in AUP, will be helping us in linking the HPMP business with the building sector codes and standards. And allow me first to start with my presentation, giving you a little bit of background about what do we mean by HPMP and what's the objective of this session. Apparently, the building sector always look at the refrigerant side as, or the issues related to the refrigeration, air conditioning, as something that come automatically with the package. Meaning whatever there in terms of technology in the market will be deployed automatically. We don't need to be concerned about the doing some additional research and finding out what's need to be deployed and what needs to be avoided, because the market now is full of different types of technologies. But recently, and this recently does not mean over the last 2 years, but over the last 2 decades, this industry is witnessing rapid change due to the global environmental different commitments, which made a lot of development take place in the refrigeration air conditioning sector. And it's going to continue in this direction in terms of the development and the pace of the development for apparently the next couple of decades as well, till the whole world conclude again to different certain technologies that can be really named and called a long-term technology. Currently, none of the existing seems to be called with this long-term, except very few, which is still not still questionable in terms of their sustainability or affordability, technically or economically. So, to start with discussing this issue, let's very quickly talk about the motives or the driving forces coming from the Montreal Protocol. What do we mean by the HPMP? What is the contribution of the HCFC to the building sector? What are the complexities and concerns to this sector and in terms of the industry and decision makers? What can be offered under the HPMP as a project to help the building sector and the relevant sectors within the building sector? And what other initiatives that we can concern at a larger and wider scope regionally or globally? I do believe that many of you understand the background behind the Montreal Protocol, so I'm going to not speak about that, but it's all started in the year 2007 with the accelerated regime for phasing out HCFC adopted by the Montreal Protocol parties to accelerate the phase out instead of leaving it freely consumed till the year 2040, putting milestones in between, starting from 2013 to start accelerating the reduction. So 2013, 15, 20, freezing 10%, 35%, and so on. This has a very direct impact on the air conditioning industry in particular and other related industries, as you're going to see later. But why we are so concerned? There are more than 700 international multilateral environmental agreements. Why this agreement in particular? So let's just quickly speaking about some facts about Montreal Protocol. It's the only agreement globally which has a universal consensus, meaning 197 party to the Montreal Protocol out of 197 party to the UN system. So there's no way out. It's either you are in or you are not there. Even the Vatican which is usually does not join or ratify such environmental agreements, is party to the Montreal Protocol. Even the newly established countries like the Southern Sudan, the East Timor, all these are becoming parties to the Montreal Protocol. The third point is, the second point, that there is a binding amendments and agreement and adjustment to this Montreal Protocol, like the adjustment that I just recently showed in the year 2007. So whatever is adopted by the Montreal Protocol is compulsory globally and need to be followed. The third point is that we have a very strong financial mechanism to facilitate the technology transfer and assisted many countries. I'm going to see an example from Lebanon after a while and some feedback from the region from Bassam later on. And finally, as I mentioned from a while, there's no way out. Being in non-compliance, meaning that you are putting your country in a risk to be suspended from this treaty and facing maybe consequences later on by not being able to export those substances which are crucial to the different sectors, including the building sector. So HPMP, which stands for the HCFC Phase-Out Management Plan, is an overarching strategy with an objective to phase out the HCFC in a gradual stage approach and make sure that this phase-out is sustainable. That means that whatever we achieved, it's not reverted back again. We have to make sure that whatever we are doing on the ground is integrated with other national programs, it's not contradicting or conflicting. And we need as well to delegate the responsibilities in terms of phasing out HCFC with different other authorities. We don't need to keep the work only directed, managed, and monitored by the Ministry of Environment or the respective authority. We need to make sure that other authorities take their share of responsibility. So the institutionalization of the business is very important as an objective for the HPMP as a strategy. The key characteristic of a strategy and the advantages of it, that it has a stage approach. You have to identify priority, compile detailed information. You have to be dynamic and flexible. You have all the flexibility to move between different components, to adjust the components while you are progressing, because it's a long term. It's taking countries from the year 2013 till 2030. So it's almost 20 years strategy. How to gradually, safely, economically, affordably implement the phase-out program. And it's challenging as well, because you need to come up with new ideas. You need to think out of the box. You need to think how you can come up with new ideas to solve some problems, as you're going to see after some slides. So what are the HCFCs? Many of you knows what this term stands for, hydrochlorofluorocarbons, which comes after the CFC's age, the chlorofluorocarbons. The most four famous substances are the R22, R123, which are basically used as refrigerants, but the R22 as well is used as material and blowing agent to support the 142B in some of the foaming industry. And the 141B is being used mostly for foaming industry, but as well the refrigeration air conditioning industry is using it extensively lately as a flushing and cleaning agent for refrigeration cycles and systems. So the two sectors that related to the building sector that consumes the HCFC are the building insulation, either the extruded polystyrene boards or the polyurethane insulation, either are in board form or in spray for insulation of surfaces, and the heating, ventilation, air conditioning, and refrigeration systems. Either it's air conditioning or refrigeration application, but the majority of the consumption goes for the air conditioning, despite the fact that there is a trend of increased consumption in the refrigeration sector that it's currently unforeseen or unattended by most of the countries. Before starting in any strategy, you need to compile the necessary important information that can make you build the strategy appropriately and comprehensively and without missing any of the key important elements. So you need to assess the large end user sector, the service sector, the equipment manufacturers, the importer, exporters, as well as the refrigerants and the materials, either equipment or refrigerants. So you need to come up with a detailed information, and you need not to miss as well the servicing capacities in terms of technicians, vocational training capacities available in the country, and the standards and codes and norms as well that need to be considered while implementing the strategy, because some of the standards, as you're going to see, need to be adopted or adjusted or revised in order to accommodate the alternatives that's going to be presented as a replacement for the HCFCs. The overarching regulatory framework for implementing an HPMP include different proposals, different regulatory measures that the country can implement, including the control of consumption. And the term consumption, by the way, under the Montreal Protocol mean importation. It's the definition is called import minus export, not the use within the country. The control of equipment that deals with this HCFC, like the air conditioning units and systems, regulating the consuming sectors, those who are using the refrigerants in terms of servicing and installations, and regulating the servicing sector as well, and doing a proper cross-cutting labeling and record-keeping standards or requirements or codes in order to make sure that you will maintain having the enough information available during the implementation of this long-term strategy in order to measure the effectiveness, to report back to the different international entities where you need to report back, as well as taking corrective measures to the strategy as you progress. But before introducing any of those, there are 4 items or 4 elements that you need to put into consideration. You need to think about the enforcement mechanisms and their feasibility. It's very nice to put a system to regulate the servicing sector, but do we have the capacity to enforce this? And what are required to do it? You need as well to compile enough information and data to ensure that there's a cross-checking exercise being done to make sure that the data and information you collected and you are basing your strategy on it is reliable and validated. Third, you need to make sure that you have enough capacity building programs after you instate or initiate this regulatory measure to implement, to assist the implementers of this measure, of this regulatory frameworks to implement it properly. So you need to build the capacity of the different authorities. So in a nutshell, you need to make sure that the approach is comprehensive. We don't stop in the middle of the way. It's not about issuing a new regulation and leave it in the, and put it in the National Gazette and that's it. You need to make sure that you take it till the end of the stage. Now let's talk about complexities when it comes to the phase out of HCFC. The problem the world facing is that majority of this graph is taken from a special report developed by the IPCC Intergovernmental Panel on Climate Change and the Technology Economic Assessment Panel of the Montreal Protocol, which was about safeguarding the ozone layer and the global climate system. And it shows how the ozone depleting substances, which we are removing, is also contributing to the global warming, and fortunately we are doing a dual benefit to the ecosystem and the climate of the earth. However, most of the alternatives being available commercially over the last couple of decades and eventually for the next couple of decades as well are with higher global characteristics, high global warming characteristics. Therefore, we need to be careful what to introduce in terms of alternatives to the current existing HCFCs like the R22, which we mentioned. CFC now is part of history. We should not be find it except in history books or different lectures. Now, if we go specifically, what are the concerns of the industries and the decision makers in the region here, and particularly in the Middle East, and most of the developing countries as well. If you look first about the air conditioning industry, I'm going to focus more on the air conditioning in this presentation because I think this is the key challenging sector compared to the foam sector, which is not that challenging in terms of finding alternatives like the air conditioning sector. The sustainability of any offered alternatives currently being introduced globally, this is a key concern. Availability of components to support these new alternatives. There are nice fancy alternatives being offered, natural refrigerants, they call different types, but do we have enough components to serve where we can introduce equipment and system and service them and maintain them properly as a long term? The cost implication associated with the final product with deploying such long-term refrigerant, and the market readiness to handle this refrigerant and the systems operating with those alternatives in the future, and a specific concern for some countries like the hot climate countries. We're going to talk about this tomorrow a little bit in the keynote lecture, which is how we can harmonize policies among different countries where you have common markets and interlinked markets. as well as how to ensure applying at least single solution for each category. You don't want to find a window unit or a split unit in the market in a few years from now with 3, 4, 5 different refrigerants being deployed. This is going to create a chaos and a mess in the market. If we go to the side of the governments and the decision makers, they are very concerned about how to timely meet the obligation under the Montreal Protocol. But in the same time, they would like, while doing so, try as much as possible and feasible to leapfrog the use of any high GWB options, because everyone knows that the high GWB alternatives, the high global warming alternatives, will eventually be phased out one day or another. Whether this day is a short term, medium term, long term, but it will not be there forever. And we need also to make sure that whatever is adopted is really well assessed, because there is a limited research capabilities and capacities in many developing countries. So we are unfortunately taking what is offered to us by the market and the global industry. And there's also an urgency to link whatever work in the refrigerant side being implemented with the energy efficiency program within a limited standards and norms capacities available to address this issue in particular in many countries. And finally, the fiscal implication of such alternatives adoption, how this will affect the public budget, for example, in any country in terms of additional cost to the equipment prices. If we look at the HVAC sector, and who are the main groups involved in the heating, ventilation, air conditioning, and refrigeration sector. We have the manufacturers and importers of systems. We have the contractors and servicing sectors. We have the consultants and end users, and those who are the real buyers of the systems. And we have the government associations, and those who are the developer of the laws and standards and norms that govern the work. I put it in this order in particular because what happens usually is those are the sector, the end users and the consultant who determine what's needed. It depends on the requirements of the sector. And accordingly, the industry and the service providers will react accordingly to support this supply. So the top part of the graph is what we can call the supply chain of the refrigerants network. While the government and associations in many cases or in reality becoming the reactor after the introduction of the technology in terms of how to put the proper standards or the trying to put some additional measures to increase the efficiency or reduce emissions out of this introduced system and technologies. So what can be offered under the HPMP for these different groups? And let's start from the left side. For the manufacturing sector, the HPMP usually offer technology assessment and transfer services, meaning that we help them in identifying the alternatives, and we implement projects to convert their industries to alternatives technologies. While we are assisting the government associations in developing the relevant standards and codes, and we work with large end users through disseminating the proper information and building their knowledge for the future. But we spend a lot of effort with this sector because most of the emissions coming from this sector. So we need to put the good certification practices and schemes, as well as continue doing training and capacity building programs. And this is in a nutshell the types of activities that we usually introduce within the HPP in any country. Finally, I'll take this slide as an example, only one slide, in terms of standards and codes that we mentioned here that we are assisting governments and associations to develop sometimes. If you look at the refrigerant in particular and issues related to the Montreal Protocol and the future of refrigerants, you will have 6 categories of standards and codes that need to be considered, and in terms of update, revision, or introduction if they are not there. The refrigeration and air conditioning national codes, we have, some countries have a national code, other that does not have. There's a difference between the code and the standard, and I believe that all of you know the difference. The refrigerant standards, because you need the reference whenever you accept or not or decline any type of refrigerants, even for importation. So you need a local standard to be there on ground, accepted. The containers standards, and this is always a missing part that nobody looks at it very carefully. because it's affect a lot the emissions, as well as the promoting the recovery, recycling, and reclamation business in the future. The labeling and record keeping, this is a major part which is unfortunately not well taken care of in many cases. Transportation and handling codes, it's important for handling the refrigerant safely. Particularly, most of the future refrigerants are with some hazardous characteristics, in particular flammability. And servicing codes of practice, and this is including the certification schemes that need to be there, but without putting codes of good practice, you cannot establish a certification scheme. So this is an example of the details that we need to go in each country in order to ensure that we have a comprehensive technical and institutional setup to support the HCFC phase out. Finally, this is an example of what types of regional activities and approaches and international that we can do. I will give two examples at the governmental level. We have two initiatives now we are trying to implement at the region in West Asia. One of them is an initiative to promote establishment of certification schemes for technicians. And another one is a regional approach to update the standards and codes, which is mostly needed for the phase out and introducing of alternatives, long-term alternatives to the HCFCs. At industry level, we've been working on over the last 3 years in different types of partnerships and initiatives. One of them is cooperation, like for example, between UNIP and ASHRI. There were many activities and joint projects being implemented under this initiative to support the phase out of HCFC. Technology assessment, this is a major project which is called BRAHA globally to assess the low GWP alternatives for air conditioning industry, and we're going to present it in details tomorrow morning in a keynote presentation. And one of the also key achievement through the partnership with the association and industry was the Aramina, which is an initiative by UNIP and AHRI to establish the first regional refrigeration air conditioning association in the Middle East and North Africa. I will stop here because I know that we have a limited time, and we'll allow Mr. Mazen to give his presentation. Thank you. I think we can take comments and questions at the end of the session.
Good morning. Thank you, Ayman, for your extensive talk about HPMPs and in terms of Montreal Protocol and what we are doing in the region in terms of the phasing out of HCFCs. The National Ozone Unit in Lebanon was established in 1998 at the Ministry of Environment and managed by UNDP. It's a project fully funded by the Multilateral Fund to the Protocol Montreal, which is a fund to support developing countries to phase out ozone-depleting substances in their production facilities in their countries. One of them is Lebanon. We signed just a little brief about Lebanon and Montreal Protocol history. Lebanon signed the Montreal Protocol in 1993. And we started in 1997. It took us 4 years to understand why we signed and how to implement. So it's not bad. Since 1998, we first phased out the CFCs. As you all know, now CFCs are phased out, and you cannot find CFCs anywhere in the world, and even in Lebanon. The cost of the first phase of phasing out CFCs was around close to $10 million, where we reconverted all the industries in Lebanon to non-CFCs. Now it's going to be a brief presentation on what are we doing in Lebanon in terms of the phase out of HCFCs. I'm not going to talk about HPMPs and the history because Ayman, I guess he briefed on what is going on under HPMP and Montreal Protocol. In Lebanon, in 2011 we signed an agreement with the executive committee of the multilateral fund on the phase out of HCFCs, and we started the work in 2011 with a budget of around $2.6 million for stage 1 to phase out a certain amount of HCFCs from our quota in order to comply with the Montreal Protocol compliance, to comply with the Montreal Protocol milestones, where, as Ayman said, we have major targets to achieve. First one is 2013, the second one is 2015, and then 2020, 2025, and until 2040. Our stage 1, there was a combination of activities that we do is mainly the technology transfer and the technical assistance to the industry, as well as training programs and of course policies and regulations, coordination, monitoring, and of course awareness and communication. Let me show you before showing you our consumption levels and our trends of consumption of HCFCs and importation. We targeted a certain number of consumption in the country to reduce around 20 ODP tons of HCFCs, a combination of two products, 141B used in the foam sector and R22 used in the refrigeration sector. 20 ODP is something around 200 tons, metric tons of these HCFC chemicals. These will contribute for Lebanon to comply with 2013 and 2015 milestones under Montreal Protocol. This will definitely, as well as you know, because phasing out HCFCs will contribute positively under global warming potential, which will save around 0.66 million tons starting in 2015. This is our consumption trend of HCFCs in Lebanon. As you can see, in the year 2000, it was something like around 256 tons. In last year, or before 2010, it reached something like 1,100 tons, and now we are going down due to Montreal Protocol. I'm sure somebody is going to ask me why in 2008 it was 432, and in 2010 it's 167. Okay. I have an answer for that.
Can I ask you?
Yeah, you can. But you know the answer. Okay, this is our HCFC consumption. This is a projection of our consumption of HCFCs. I'm talking about these two products, the R141B and R22. It's because mainly these are the two chemicals or refrigerants or blowing agent that we use in Lebanon. This is the trend. This is the baseline. Our baseline is as you know, under protocol, the baseline is the average consumption of a country of 2009 and 2010. In Lebanon, it's something like around 1,000 tons. This is our baseline. And we have to comply with this baseline in our reductions of consumption of HCFCs. As you know, I mean, for sure, why there is a certain increase in our consumption, because the country is, the industry is expanding, and mainly the refrigeration sector is expanding with a massive quantity of air conditioning system around, coming from different countries, good prices, cheap prices, and even, poor people can now easily buy an air conditioning unit for his apartment. Now, with the Montreal Protocol assistance, what I mean is Montreal Protocol assistance is the funding scheme that is provided by Montreal Protocol, where most of or all our industries are eligible for funding to reconvert their industries. As you know, in Lebanon, we have one major manufacturer of air conditioning units, residential, is Lematic or Concord. That factory was converted just recently to a non-ozone depleting substance, which is R410A. As you can see, our projection for our consumption of Lebanon, complying with Montreal Protocol, where we should be under the baseline. So we are expecting that by 2020 to reach a figure even less than 650 tons of HCFCs. This is the consumption distribution of HCFCs in Lebanon between 2009 and 2010, and as you can see, the HR22 is around 70, which is 70% of the consumption of Lebanon, and R141B is around 30%. Of course, we approached a strategy to comply with the Montreal Protocol. I mean, what we did is we applied. We focused on the manufacturing sector. We focused on certain criteria and eligibility for certain factories where we have a limited time to implement the stage one, which was between 2011 and 2013, because 2013 we have to comply with the Montreal Protocol, which is the freeze of our consumption, and 2015 is a 10% reduction. So what we did a strategy to work with certain type of industries, where we have chosen two big industries in Lebanon who were very well established and easy to work with, because as you know, in Lebanon the industry sector and the service sector is informal. Most of them are informal. You can go to a service center where you want to fix your car. This service sector is not certified. It's not official. It's not legal. The sector is really informal. It's very hard to work with. So what we have done in order to comply with the Montreal Protocol is to choose certain type of industries where we can really rely on working with them on time and to achieve our goal, which is the reduction of the 20% of the 20 ODP tons of HCFCs. So those two companies were one air conditioning company, which, as I've just mentioned, is Lematic Concord, and the other factory was a foam industry, sandwich panel used for insulation. It's a Dalal Steel company. These two companies were implemented, and projects were completed early this year, and we were successfully phased out their consumption of around 200 metric tons of HCFCs, which is equivalent to 20 ODP tons, approximately. So now, with these two factories, Lebanon was able to comply with the Montreal Protocol, with 2013 freeze of consumption, and in our future, or the second milestone, which will be coming in 2015, we will be able to meet this target. The two sectors, the air conditioning sector and the foam sector, we have chosen one of the alternatives in the air conditioning sector is with a zero ODP, which is the 410A. But unfortunately, it's a high GWP alternative. At that time, when the project was first approved in 2011, we were very reluctant to choose any hydrocarbon technology. So maybe what we are doing now with the Limatic industry to try to reconvert one of their production lines to a hydrocarbon technology. We're not sure about it yet, but maybe soon. The other alternative at the foam industry was purely reconvert to a natural gas, as you know, a hydrocarbon, which is cyclopentane. Now, these are some photos of the air conditioning systems produced at Limatic with the refrigerant 410A. And this is another photo for Limatic, for the Lal Steel, where now they are producing sandwich panels with hydrocarbon cyclopentane. It's a huge factory. It's in Bekaa Valley, producing millions of square meters of sandwich panels. With this reduction, as you can see, we met the 2013 milestone under Montreal Protocol compliance due to the successful conversion of these two industries. And we are expecting that by 2015 to meet also the second milestone. Now, of course, stage one is almost completed in terms of reconverting these two big projects and compliance with the Montreal Protocol. Of course, as you know, in Montreal Protocol, there's another stage, which is stage two, is to complete our activities. Our plan and strategy is to target the remaining foam industry and part of the refrigeration and service sector in the years 2015, 2022, and by 2025, I don't know, I'm still alive, my son will take over because I will retire, or my daughter. My daughter is studying architecture. I don't think she will fit. My son will be studying law, so he will fit, I think. So, for stage two compliance, these are the milestones, the Montreal Protocol milestones. In 2025, we should expect around less than 200 tons of consumption, only in the service sector. So you will not see any new industry or remaining industry using HCFCs. And last but not least, our projected consumption of ODSs in the foam sector, we are now around 294 tons. We are expecting in our stage two to reduce to 25 tons. Or maybe zero, I don't know. We'll see how it works. In the AC and refrigeration sector, our consumption is around 237 tons. We are expecting to go for 160, and in the service sector, which is it's a very hard sector to deal with. There's a lot of work to be done in this sector, in the service sector. It's 452, and we're expecting to reduce by 400 tons. We will leave the remaining activities or work for the service sector after 2020. So this is our strategy. But of course, reconverting and industry, helping the service sector, assisting governments and implementation of Montreal Protocol, but without the regulations and taking into consideration the legal aspects of our work, we could not achieve our goals. So we of course we have legislations on CFCs and HALENs. Now we are working on legislations for HCFCs, and maybe later on, you will see some regulations on HFCs. We've done a lot of awareness campaigns. We've done a lot of work on the awareness front for the ozone depletion problem. Awareness to students in schools and academia and government, public, and at the national level and the regional level as well. We have a Facebook. I don't know how to use it, but we have a Facebook. And you can, I don't know, what do you call it? Like? I don't like. You can like us on our Facebook. We have a lot of information on Facebook, really. You're welcome to join us, and thank you. I'm sorry my presentation was very short because we are going to leave some space for Dr. Samir Trabelsi. He have around 120 slides. So if you wanna run now, guys, you can run.
That's the revised one. Thank you, Mazen. Actually, I want to thank Mazen for more than one thing. Mazen, Lama, and the office there, they nominated me to represent Lebanon on a technical committee, and I'm really proud to do that. It's a technical options committee where we're trying to find out the alternatives. So this is the good work. I'm glad to see all the money because I'll be talking about the money at the beginning. Yeah. And the second thing I wanted to say, I see one person here who maybe him and I were responsible for the 0.6% that you showed over there, this 123. So you might want to do something about it, Gabby. Anyway, okay, let's talk a little bit about the region. Mazen showed you the money, and you think that, getting the money from the multilateral fund is something simple, you get it and you spend it. But I just want to show you a little bit how this money is being attributed and how it's being spent. Before that, the possible achievements for the first phase, as Mazen has shown that, and it's really typical in the region as well. When we're talking about the region, mostly it's West Asia, but also we can expand it to North Africa as well, because there's a lot of similarities in the region. So of course, as Mazen said, we start with the foam and then move into manufacturing, and the last thing is the servicing. I think this is important for the manufacturers amongst us here, also for the service companies, and that's why you see these programs progressing in this way. Foam, they have found a good solution. I think for the manufacturing, we are trying to find, and Awal here is with us in this journey. But the servicing is as Mazen said, the sector can be informal, very huge, and to be able to address every little shop, train the people, put the awareness, and then make them use the right practices is something which is quite difficult. So let's talk about a little bit about the money. I saw that Lebanon spent about 2 million in the first phase. There's about 5 million more to be spent. So this is really the measuring. I call it the first tranche or the first phase. It was actually it's the tranche of the phase. So the green, of course, is less pain, and the more painful, as you know, the stress goes out to red. And this shows what I was saying and what Mazen presented, that you start with the foam, you have all the answers, so you don't need to stress a little bit about it. And then you have what we call investment projects, and these investment projects is like the one, for instance, at Limatech, where you're dealing with one company, and this company converts from one particular from HCFC into something else. The pre-branded polyols, but I don't think that you have them here. They're also used in polyurethane extrusions and so on. These are they don't actually count in the ODP consumption or in the tons consumption, but they do include the 141. And then, of course, Ayman and Mazen talked about training, about the servicing sector, and about setting quotas, which is coming. You know, like, I mean, you know that at a certain point, you know that you can consume only the 400 tons. So even if the country needs 800, you have to consume 400. So a quota has to be set. And where is this 400 going to be used? This is the important thing. And then I think the most important one is the ban when you say, okay, starting this date, for instance, you know, the foam, the 141B, there's not going to be any import of 141B, so you put a ban, you put a date, and you have to implement it. Now, this is the money part. You know, the easy part seems to have the more money, at least from my point of view. But Lamak, you can correct me, and Mazen, of course. Ayman has more experience in this. What I'm trying to show here is the more the pain, the less the gain. So the easier ones seem to be rewarded more heavily than the ones that are more difficult to do. And it wasn't planned this way, but I think the practice, the implementation, actually turned out this way. So this is just to give you a feel of what the ozone offices in the region, and particularly in Lebanon, have to go through, because they you know, wherever they have more money, they can implement it easily, but they have to do a lot of work with practically very little money, because there's no money tied to bans, for instance. And the ODP tons is the actual equivalent, what was shown, for instance, because we have to add two substances, 22 and 141, that have different weighting on the ozone, in different effect on the ozone. So we multiply them by a weighting factor so that we can add them, and the tons become more significant. Because if we add actual metric tons, then it's not the same effect on ozone depletion. So what this slide here shows is that, you know, of course, the more the pain, the less the money. But however, you know, how much we are phasing out differs. It could be, you know, it's for instance, there is little phase out or zero phase out practically from training, which is directly felt. Indirectly, it's there. You know that when you train people, they're going to do a better job. There'll be less leaks, but you cannot measure it. While you can measure a project like Limatech, for instance, they know they were consuming 200 tons. At the end, when it's done, when they're converted to 410, they're going to consume zero. So that you can measure very clearly. And that's the basic thing that we wanted to say here, is that the work that is being done needs the support of each one of you. And I see in the crowd here, we have contractors, we have manufacturers, we have you know, institutional people, and so it's quite a mixture of effort in order to spend that money. So don't think the $5 million that they're getting is easy money that they spend. What are the best practices from the region? So this is what's included. What's normally included in an HPMP strategy is, you know, implementation of best practices. This is the first thing. In any strategy, they start and say, okay, this is what we learned from the CFC. You know, we phased out chlorofluorocarbons in 2000 and 2010, correct? And now we can use the same methods to do that again. Recycling and reclamation is a big thing, and that is a real winner. You know, it's easy to implement. It takes money. You know, you have to have a center. You have to have a place where this recycling material comes, and so that it's reclaimed and resold. If there is no market for the recycled material, there's practically no reason to do it, because you cannot just take it and you know, recycle it and keep it there. So you have to make sure that you can sell it out again. Of course, we have to set quotas, pilot projects, and then there are some end-user programs that I'll show you a little bit of an example. Commercial refrigeration seems to be a lot neglected, and thanks to Lama, you know, we added it to this presentation because there are, in every country, there are some hidden commercial refrigeration, and some of the commercial refrigeration applications are really heavy users. They're big consumers because of the nature of the equipment, the leaks, and so on. So there's also the retrofit and the conversion of equipment themselves. And Ayman mentioned the UNIP ASHRAE cooperation. Actually, he was influential. Mazen remembers Lama also. We had our first meeting here. The global cooperation started actually in Lebanon because the first meeting happened here, and ASHRAE said, we can help you identify the equipment so that you can retrofit it and and remove those refrigerants from it. And now it's a global agreement, and it's much more bigger than what it started. But I'm really glad that it started from here. It was actually at a hotel in Hamra Street, as Lama recalls. Okay, the implementation of the best practices. Here we're always saying that whatever you learn here today, I'm sure you will forget maybe in study says about 2 weeks, but people my age, maybe 2 days. I tend to forget a lot. So if it's, whatever you learn, if it's not implemented right away, it's going to be lost. And then, there has to be material about this training. If you don't have this copy, if I don't have it and reread it or write it, I will not be able to retain it. So this is about what we have learned from the region, that the implementation of the best practice, it has to be followed through. The Reclamation Center, actually, it's a win-win, like the title of this conference, because whatever you recuperate, reclaim, and reuse, the refrigerant itself is non-flammable, it's non-toxic. People know how to deal with it, so there is no real risk in doing it. There are other practices, for instance, at drop-in, where they take 22 and put in hydrocarbon, and they're doing that in some countries in Africa. And if the equipment is leaking and you drop in hydrocarbon, it's going to continue leaking, and it'll be a big risk factor. But with the recycling, there's practically no risk. The quotas and licensing, here the stress is on market surveillance. You can put a quota, you can say you need a licensing system whereby you cannot import unless we issue a license which is approved by the Ministry of Environment and the Ministry of Commerce or whatever it is. But if at the end we don't control what's coming into the market, contraband is going to start, illegal stuff is going to come in, and that is more dangerous, because the illegal stuff coming in, we don't know what it is. They can say it's 134A, and it turns out to be something explosive or flammable, and they put it to use, and it will be very, very dangerous. And it was the experience from the region and beyond, is that once you put this and once you bring this idea of market surveillance, it's the industry itself that helps. Because, if you're an importer, a legal importer, and there's contraband coming in and it's dangerous, you want to tell about it. Or if you're a user and use it one time and you charge it in a unit and the unit explodes, you want to tell the ministry that this is happening. So this is why we talk about market surveillance. About the pilot projects, the strategy at some stage, Mazen didn't mention it in the first stage, but maybe later, there's a conversion project where we take one pilot project and show that by converting it, you're actually, you can convert it with the savings. Because what's being converted, and this is the subject of this conference also, is about energy efficiency. You're taking something which is 20, 30 years old and converting it to a new technology. It's going to be more energy efficient, less leakage, more tight. So the money that you save on recharging it every year and on the energy spending, the payback is very short. And the end user targeted programs, of course, here for instance, we talk about the energy benefits, about the climate benefits, and what the strategy stresses here is your technician, for those who have technicians, is really the best ambassador, and you probably have seen it yourself. Somebody comes to fix your fridge or your whatever, AC or TV, and then you ask their opinion, and they tell you, oh, this is a piece of crap, like, why don't you change it? And so you ask what's available, and he tells you about it. So sometimes what you try to do through awareness campaign, a simple person with an overall can do it much better because people trust him, specifically if him or her, I don't know if they're lady technicians, they can convince a lot better. So some of these programs are also targeted towards technicians. The commercial refrigeration part here, we put it on simply because I've been in the area, and unfortunately the alternatives for refrigeration seem to be more difficult than to find than the alternatives for air conditioning. For the simple reason is that they do exist, and the alternatives for refrigeration have been the alternatives are there much older than what we're trying to find for the air conditioning, like ammonia, for instance. It's been there for ages. As a matter of fact, there's a nice slide which shows almost like a cycle, like a circle, and it shows where we started in the 1800s or early 1900s. We're going back to, which is the ammonia, water, and the hydrocarbon, all these what we call natural refrigerants. All this technology was available before, but not in the same way that's available here. And the other thing that I want to mention about the commercial refrigeration is that unfortunately there are cold stores now being built with 404A. And 404A, it's an HFC, it's zero ODP, zero ozone depletion potential, but it has a very high global warming potential, 4,400. And this is the first on the list on any targeted F-gas or high GWP gas reduction or phase down, as they call it now. As a matter of fact, the European Union, for instance, they have it on the list for, 2017 or even 2020. So the technology is going to die very soon. And for somebody to invest in a project now with 404, I think it's a pity. It's a waste of money, because they'll have to change it later, it's not going to be supported. Anyway, I don't think the United Nations the Multilateral Fund would support something like that. One thing to talk about here, Ayman talked about codes and about standards, is about safety standards. As Mazen said, they're thinking of switching one of the lines into hydrocarbon. Hydrocarbon, of course, when people tell you, I don't want to put a hydrocarbon gas in my bedroom, and we have a colleague who mentions that he likes candles, and if he's letting out the candle at night to be romantic with his wife, and then there is a leak, he's going to blow up the whole thing. So we always laugh about it. But what I want to make the point here is that there are international standards like the ISO about the usage, the quantities, and so on. What needs to be done is the implementation on a regional scale, on a country scale, and this is a work. Every country have their own standards association or standards organization, and the coordination between the ozone unit and the standards organization is very important, because if we bring the hydrocarbon without the real specific country national standards and codes, we're actually not doing the technology a good review. Finally, on energy, the energy regulation also in Lebanon, there are codes, and I understood Lama presented a couple of years back on the refrigerators, I guess, and it was supposed to be propagated into air conditioning and larger equipment. Maybe Samir will be talking to us, one of his 120 slides about it. The retrofitting, this is what I mentioned to you before. We put it here because in the region, specifically when we talk in Africa, we tell them there's one particular organization going around and say you can use it as a drop-in, but the implementing agencies are telling them, no, please don't, because the equipment that is designed for hydrocarbon is not the same as the equipment that we had for 22. They have spark-proof, electrical, and things of the same. Okay, the final thoughts. Where is this coming in? I think I'm going back here. Final thoughts for the NOU. I don't think we need to do that. Maybe Mazen, you and I and Lama discuss that later. But I urge you all to read the report by this RTOC, which the new one is going to come out in 2014, and my contribution to it was about sustainability. So it really meshes also with this. What I mean sustainability is that we use these refrigerants. So what do we do with them? And it's about recycling, but also about energy efficiency, about reducing leaks, and so on. The Praha project, tomorrow we're going to talk about it, but I put it here just as an enticement. There are 3 sessions going along, and I want you all to be in. No, it's a keynote speech, so I don't have to. No advertising? Okay, great. But you will learn about the Praha tomorrow. Thank you very much, and now let me introduce Samir, please. Yeah, 29 plus.
Yes, good afternoon for all. Thank you for being here during this remaining part of the session. I thank all the presenters so far. 3 of them, 3 gentlemen, talked about practically everything about HPMP. However, I have still to add something, not in the 120 slides. It will not be at all 100 slides. Otherwise, you will not have lunch today. So allow me please to go and skip a couple of slides just to save time, but at the same pinpoint some of the points that I wanted to share with you today. So in principle, the presentation was supposed to cover the use of refrigerants, because we're concerned with HVAC mainly. Of course, this substance can be used in different sectors like foam. Also, I'll talk about the HMP objective, as mentioned also previously by Stes Mazen. Then I'll hint on some of the building codes we have in various countries in the region. And quickly speaking, I'm going to mention the ASHRAE position on certain refrigerants as well as standards. And more importantly, in this presentation, I'm going to talk about the barriers and how to move forward. So, refrigerants, what for? Heat transfer, take it from one source and dropping into another. Thermodynamics laws, first and second. And I'd like to talk about the reason why we're looking at this subject today. And maybe it goes back into the year 2002 or 2003, when personally was involved with the ozone office in Beirut with the UNDP at the time, and said, and I still now believe it's more correct, we had an issue, something called ozone layer depletion. The whole world, scientists, Montreal Protocol, amendments, everybody was concerned about the refrigerant, the bad refrigerant called CFCs, whatever. And unfortunately, the plans came out to quickly get rid of the CFCs without getting something like a feasible replacements. Of course, we jumped from CFCs into HCFCs at that time. And now we're trying to get rid of the HCFC today. And then today we're moving into, and as before, we are moving into other substances. Now we're discovering that they are problems with respect to the global warming issues and so forth. So in fact, the whole world is trapped, and I said it's trapped by trying to phase out one substance, that it was called under the headline called ozone layer depletion, and we moved into another problem which is now called global warming. Now, who says that maybe in the 10 years to come we will be having a third issue resulting from the use of substances that we assume currently that they are solving our two issues and could be probably causing the future problem. Now, why is that? Because of the time needed to rush into phasing out a certain bad material, not giving the right time for defining or coming up with a substitute that will not only save the problem of the existing problem, but also it should have been a substitute that will last and become sustainable. So this is the whole world is facing this, and unfortunately, this means that you're going to have the whole world being investing in phasing out at one stage, going into the second stage, building up such budgets, and unfortunately, it's who to blame? Probably the scientists, the researchers, the air conditioning people who did not spend sufficient time in coming up with ideas or results that would mean that we are going to solve the two problems we know of today, and probably not have the opportunity to create a third problem. So this is my thought about phasing out in stages. We pushed people to go from CFC into HCFC, and now we're looking at CFC as a bad substance. Of course, it was bad from the very beginning, but now we're moving into different non-ODS, we call them, fine, but we know in advance that such non-ODS, like what you have described so far, gentlemen, we talked about global warming and use of 404 and 407 in the future. So this is in your hand now. Think of it, how to cope with future problems in the future, with the problems. So let me go straight forward into objectives mentioned by Mr. Ayman this morning. We talk about regulations on HCFC, quota system, HCFC control measures, HCFC-based equipment, energy efficiency. This is more delicate item, energy efficiency. Now we see what happened with the code in Lebanon in regard to energy efficiency. Responsibilities of stakeholders is a problem. Innovation of other non-ODS, as I described just before. So, to invent a new non-ODS, you need to consider problems that could be created, but in addition, you have a problem called capital cost, operating cost, equipment and air conditioning size and location, temperatures, ambient, you have hot climate, you have considerable temperatures, whatever. People to run to use the system, to run the system, they have the valid information, and more importantly, the stakeholders. So, the current, I want to describe this a little bit about Lebanon. We talk about current construction law. Unfortunately, you go through the construction law, and we have a couple of people here who have been dealing with that need to change this construction law for the last 3 or 4 years. Nothing had happened, because the current prevailing construction law does not describe anything in relationship to energy efficiency, nothing with respect to the indoor air quality, environmental quality, and also nothing to talk about environment. And unfortunately, this construction law in Lebanon produced all the buildings we see around. It has nothing to do with EE, nothing to do with environment, nothing to do with environmental quality or water. Why is that? Because it's so rigid. It was described in the 1950, let's say, amended in 1970, with no intention to look how it's going to impact environment, how it's going to impact the consumption of energy in this country. And from this experience of the last 3-4 years, and Rabia is here today, may share with me saying that, trying for the last 3-4 years to twist one of the clauses of the construction law to save energy. It's so difficult. It's so difficult in Lebanon. So how will it be, difficult or not, if you want to come forward and say the substance we're talking about, it may cause may cause global warming, and we need to look how to phase it out or do something about it. Unfortunately, this is the system here. We have laws that it takes you so much to twist them and change them, and it will not happen. So one of the impediments for not being able to quicken the phase out of many substances is because of the difficulty in addressing a change on the code level. And I believe Mr. Mazen can share also how difficult it was to reach a day today with the support of the international community, to reach a day today to say, yes, we don't have CFCs. How much we've spent efforts visiting, consulting, awareness, pressure on the parliamentarian or even the decision makers in the cabinet to reach that. So we could imagine what's going to be required to do a change now in the non-ODS versus what the previous efforts of ODS. So it's difficult. Now, because it's difficult, we cannot stand still. You need to move forward, and hence the invention of rating systems. That is not only in Lebanon, worldwide. When you are facing certain difficulty in penetrating a certain clause of a law, then you try to, which is mandatory, you try to go into the voluntary direction and create something, some attraction by call it a voluntary rating systems. One of them, or several of them you have heard of, whether US, British, and even Lebanese. In Lebanon Agreement Council was successful in developing a rating system called ERS for commercial existing building. Of course, you will get a point if they find out in your building you have used non-ODS. So that is only the voluntary way of saying, yes, you deserve, unfortunately, because we cannot move and make a mandatory decision on that. Now, of course, there are areas discussed before by the three gentlemen. I want to go into the barriers and share. Now, this is the ASHRAE position statement on refrigerant. They move from CFCs quickly into HCFCs. They have quickened the phasing out of HCFCs. And now, maybe we look at this, we see as if natural refrigerants, including the hydrocarbon, would be favorable today, HFCs and HFOs as well. Again, who is going to be blamed? The scientists who did not, with the same pace of trying to crash on the use of refrigerant ODS and non-ODS, it's the problem that the scientists could, or researchers could not go up along the same pace, and hence this is what we have today, a problem. We don't have a substitute that we know for sure that this will not raise any future issue. At the same time, we are asking public to suffer by investing and by causing problems in the market as being seen by the Ozone Office. So there are standards, ASHRAE, are published, available. I ask everyone, if interested, to go into the details of such standards. Mainly, a refrigerant would be, in any publication, would be concerned about safety first, and then durability and cost effective as well. Now, barriers, and I think you share with me lots of them. Regional air conditioning system manufacturers, they are used to a certain way. Now you come and tell them this refrigerant you've been using for the last 100 years, try to get rid of it and get something new. All right, they're stuck. They have their laboratories, they have their consultants, their researchers, they're stuck. As well as with the global air conditioning technology providers, likewise. Electromechanical consulting companies and consultants, we need to start from that point. Tell them that this is wrong if you continue specifying certain equipment that you may find that it will cause or add to the problems we have, the issues we have. Research institutes and centers, we lack them. If we have, maybe they are not interested in our subject here. The standardization authorities, or even in our country, we call it the standards called LIBNOR, which is the semi-governmental, it's a governmental agency department responsible for issuing standards. Also, how much they are concerned about this particular topic. Energy authorities, technical education, universities worldwide. Other barriers, talk about the sociological and psychological factors. Talk about the technical limitation, we don't have sufficient information about future. Talk about the safety, unavailability of the service of the new refrigerants, cost of it, market maturity, how willing we are to use substitute, and unavailability of standards and law. So in Lebanon, we don't have practically a code to consider currently for use of HCFCs currently. And then we have a need to do that. We don't have sufficient standards in Lebanon to convince people that this is no good for you. We don't have training yet. But all of these are projects. All of these are open areas for future consideration. So taxes, refunding, labeling, all of these are potential. But can we do that? Okay, I talked about prepared roadmap that will take everything in. I have insisted on writing involve actively the ozone office, engaging the order of engineers, very important. Timely involve LIBNOR. We don't want only to take a standard to LIBNOR, make them part of the cooking, at the cooking stage. Train custom officers, this is traditional. Strengthen the role of the Energy and Sustainability Committee at the Order of Engineers. Organize training workshops. Raise concerns and awareness through NGOs and plus other agencies. Implement quota system and license. Is this the environment we're looking for? Yes. So finally, I'd say you need to strengthen the ozone office, whether this is a good support, and facilitate dialogue between the Order of Engineers. We have over 45,000 engineers in this country. Maybe they are not aware of something we're talking about today. Create good working relationship with governmental bodies, industrial association, Order of Engineers, and other relevant stakeholders. I thank you for attending this last part, and the stage 4 I'm at.
Thank you, Samir. Thank you, Samir. Thank you, Bassam and Mazen as well. And thank you all for being with us. I think we managed to a certain extent to stick with the time in terms of the overall time for the session, despite the delay by around 15 minutes in starting up. But unfortunately, we are left with no time for the discussion. However, we are still here. If we can spare another 5 to 10 minutes for quick discussion before we allow you to go to take your lunch and break. So if any burning question, concern, comment, I think the speakers and hopefully myself will be willing to answer. Can you use the mic, Khalid? And can you please introduce yourself for those who do not know you maybe?
Yes, Khalid Al-Malham, Saudi Aramco. Actually, we are using the hydrocarbon refrigerants in our process in most of the facilities. Safety, it's a concern, but it's like any other system. You have to engineer it, you have to just take the precaution. So I think the hydrocarbon, it's the future for most of the system. Now, once we talk to a small scale, as you know, we are using hydrocarbon in our day-to-day activities in cooking and most of the major, appliances, okay, like heating and so forth. So why the manufacturers do not take really a stand, and they can design it. And believe me, most of the gas where we are going to utilize is going to be in the outdoor, the condenser side. It's not going to be indoor. I know there is a certain capacity where you cannot use indoor, but also we can design it in a way where we can utilize mechanical rooms, where we can utilize, it has to be engineered somehow. But I think the industry, they are not really serious about it. So we are engineers, we can design it the way we think it can be practical and safe.
Thank you, Khalid. I can't agree more with you. If Samir, you'd like to add something.
Yeah, I just want to add something to this. Yes, natural refrigerant like hydrocarbons, definitely it's what we're looking for. Now, safety is an issue, yes, but what about projects you talk about in district cooling? Why don't we push for district cooling projects where such plants will be set at a distance and it will not be that harmful or unsafe compared to a nuclear power plant. So this is what is lacking. Designers to come forward and say, yes, we want to place a refrigeration plant somewhere away from public, using natural refrigerant as the call today, and everybody will be happy. Safe, cost-effective, efficiency, and so.
Okay. I just want to ask you regarding your reply. I mean, as an architecture student, I'm studying urban planning, and you can see with the evolution of time, no matter how much away that you drift and you place the factory or the nuclear plant, eventually the city will catch on and it will become publicized. As you can see now, مثلا in Lebanon, taking Kura for example, and it was very distant. You would think إنه بشكة عم نحط factories, but eventually the people are catching on and the city is growing. So is it really a matter of distance or about the overall safety of the thank you.
You have a valid point. In fact, yesterday in one of the classes there was a discussion about the Zouk power plant, and I said at the time when it was built, no one have ever considered the existing current population around that particular spot. Now, that's fine. People may be annoyed today with the environmental quality of air around that particular power plant, annoyed by the transmission cables and so forth. It's very true. But what I meant by having a dedicated refrigeration plant set aside, you can protect that particular plant at a distance. Like today, you put a gas tank, you have a requirement not to be close 4 meters to that building. So why not locating such refrigeration plants somewhere where you do all the protection? Even maybe in 20 years you have public reaching that particular fence, why not? But at least you have provided a space well designed, safe, within that particular fence. If we have to, and then you can transport the chilled water to wherever. And I mentioned district cooling because now it's a move in Saudi today as much as in other countries in the area. So pre-considering the safe location, definitely it's going to be in conflict with population increase. No more suburbs. Today, all of it is becoming part of the city and the town. But of course, engineers are charged with this requirement to consider a safe, well-fenced, with a sufficient boundary, so no matter what would be the population increase. And this is the problem of sustainability today.
Any other question, comment, intervention? Well, I just wanted to bring back to the question that Khalid mentioned. Sorry. Go ahead.
I just wanted to ask regarding the comment that Mr. Mazen said about the drastic increase in 2008 HCFC.
Why you didn't mention the reason?
Never answered.
About the drastic increase after 2000. The secret.
because the Montreal Protocol at that time in 2008, we were not taking into consideration the data of the pre-blended polyols, which contains the 1,4,1-B. That's why these were not counted in our figures.
Okay. And any more?
Mr. Mazen, could it be the reason that people anticipated a plan by UNEP or by United Nations, whatever, to phase out HCFC, so everybody tried to move forward, buy something related to HCFC and wait for the fortune to come?
No, this was not the case. Because this was witnessed not even in Lebanon, but in many countries. The problem really in many countries was because prior to 2007, the HCFC data collection was not well considered by the different national ozone units.
We were not even reporting.
Yeah, we were not reporting comprehensively. So the figures were very rough, and it's best estimate. But when they started after the adjustment of the Montreal Protocol in 2007, compiled the real data, they found out the reality. So you will see the same curve in more than 150 countries around the globe, with 2007 data speaking up. But the question and the comments raised by our colleague Khalid from Aramco is a very valid question, but I would like to ask it from a different perspective. Who is leading the industry and the decision making? Are the legislator or the industry? Who's leading the development in the ventilation air conditioning sector? In my opinion, it's the industry, not the legislators, not the international community. International community reacts to the development in the industry.
Can I add one thing to your question? Is the technology for hydrocarbon for high ambient temperature countries is not there. So there is no residential units available in the market for your house in Saudi Arabia working for propane, hydrocarbon. Technology is not there yet. It's the highest temperature reached by companies, manufacturers of residential air conditioning units is something like 47 degrees centigrade, or in Kuwait, I know in summer it's 55 outside, so it's not available there. That's why we know that it is, we have a bottle of gas in the kitchen which is 25 kilos, while in an air conditioning system, a propane, maybe it's less than 300 grams. It's not a big issue. It's not the candle who will make a fire in the house, but the technology is not there in high ambient temperature. In my country, I think with the proper safety precautions, training programs for technicians, even though our technicians here in Lebanon, he puts his cigarette in his mouth and he do the fixing your car or your AC. I mean, that cigarette never leaves his mouth. This is a problem. So we'll handle this with the proper coding and training and precautions. But this is what I mean.
I think I agree with you. The stakeholders, actually, as Samir mentioned in his presentation, they are actually not putting their thoughts together. I mean, they can do it. Actually, as we speak now, we are having a research now in the company where we are going to utilize the hydrocarbon for our harsh environment, which we have already stated. In the meanwhile, economics also, it's a drive. Now, if I'm going to go and use the hydrocarbon refrigerant in our region, or should I use a refrigerant where it's really controlled by others, by certain plants? I cannot import and I cannot export and I cannot recycle. I can recycle, but I cannot utilize effectively. So hydrocarbon, it is the future, and I think the manufacturer should look into this serious matter. I mean, not only in high ambient temperature, but all. Why not in the US? Why not in Canada? Why not? I mean, they are using it everywhere. I mean, they have networks for natural gas everywhere, going to the neighborhoods for heating. Okay, now why not for air conditioning? I mean, still, even actually, they are not taking it as serious as supposed to be. I'm sorry to say this, but it is not there. I mean, thank you.
Thank you. Okay, I think we have kept you here more than enough. Thank you so much for being with us. Much appreciated. And enjoy your break and lunch. Thank you so much. This is the title of the session. My name is Ayman Kaloni. I'm coming from the United Nations Environment Program. I'm honored and privileged by the AUB to be asked to moderate and chair this session. And I look forward to the presentation of the three speakers to this session. We will have three different topics in the industrial track. The first one is dynamic simulation for the retrofit of office building, and which will be presented by Dr. Michael Bicari. And the second one is about solar energy by Mr. Hussam Chibara from Dar al-Handasa. And the third one is integrated water-cooled DRV systems and underfloor heating, which will be presented by Mr. Mohammed Haj Hassan Khatib Al-Alami. Before we proceed with the three speakers, I would like to remind the three speakers to stick with the 20 minutes allowed for the presentation. And we will be allowing 10 minutes after each presentation for question and answer. So let's start first by the first one, which is titled Dynamic Simulation for the Retrofit of an Office Building in a Mild Climate by a Means of Reversible Heat Pump, which is presented by Dr. Michel Bicari. Dr. Michel is born in Moldova in 1971, and he is holding a bachelor's degree and PhD degree from the University of Padova in Italy. His research is mainly actively related to the energy in buildings, indoor environmental quality, and the use of efficient systems for providing energy in buildings. He was tutor and co-tutor of PhD thesis and tutor and co-tutor of several graduation theses within the above-mentioned themes and topics, as well as other related topics like the heat exchangers and two-dimensional cavities and other topics. Dr. Kaldari is, since 2006, he's assistant professor in the University of Padova, where he teaches the HVAC systems and energy and buildings. He's a member of the Italian Association in the field of HVAC systems, and a member to the ISO Committee TC 205WG8. I think he may be elaborated a bit more about this acronym, what it stands for. And since 2009, he's a coordinator of the GL608SG and CT1. He published and authored and more than 150 publications presented in national and international conferences and journals. And he is a viewer of several international papers as well. Actually, his resume is quite rich, and we are looking forward to hear from him about the topic he will be presenting. Dr. Kaldari, please.
This work is a joint work between me and Clima Veneta, company which is also here, and design studio, design engineering office, studio planning in close to Milan. The main so what we will see is a presentation of this building, where we made a audit in terms of HVAC systems. I will show you what kind of energy models we used, how we tuned the model against measurements, and also we made some economical and energetic scenarios, and then work is still in progress. investigation for other locations around the world. So moving this building here in other places. The building is located in the center of London, Euston Road, close to the city. And it's an office building with around about 11,200 square meter rural area and about or more than 1,000 people work there. It's there is only one owner of this building and it's rented to the different companies working there. As you may see, this is the orientation of the building, and I don't know if it's possible to see it, but there is a huge building here on the east face, which is more than 10 floors above the. So as we will see later, of course, when dealing with an energy audit of existing buildings, there are several questions which have to be faced. First, how good are the measurements of energy or the bills which are presented by the client? Also, the quality of connected data. Sometimes you could have very good connected data, but then the question is how long you have to do the analysis. And of course, some problems related to how the building is managed. So that means internally how the people behave, and so how much they switch on the light or they use the shading systems. So if they are active or passive users. Then again, what kind of energy model you have to use, how detailed you have to go, how far you have to go in the simulation, how detailed your simulation has to be. Some questions which we have faced, and these are the usual questions for an energy audit, especially when you have not done anything about the planning and the maintenance of the HVAC systems. Almost fully placed in direction east and south. There is a glazed facade. This is the ground floor where you have double glazing, and then this is the part behind. So here you have the building, which is quite tall with this orientation. The U values of the structures are good. The building was built up at the end of the 90s, so the walls are quite well insulated for the European standards. And also, of course, the glazing surfaces are good. From the first to the 7th floor, the building has 2 greenhouses. So that means that these spaces, they are based, and it's a kind of buffer zone for between the indoor and the outdoor environment. And this is also something which complicated the model of the building. One thing, in the ground floor, there are two big areas which are retail areas, and in this case, these 2 areas, the GFD and GFA, they were not included in the investigation because they had their own autonomous HVAC system. While the section for the rest of the building and the other 7th floor, they are supplied by centralized 4 pipes heating and cooling system with gas boilers, regular gas boilers, and so here is how the model was made, more or less. We have 3 main gray zones, which are not heated or cooled, they are technical zones. And then we have the 2 we call double skin facing dates. Anyway, it's green, it's a greenhouse zone. And of course, the rest of the offices. So more or less, the analysis we have done, we have no more than 2 months to do that. So we had really to go on and simplify as much as possible the the problem. As for the internal gains, we used this shape on the left, this internal gain shape, which is quite usual. There are many works in literature showing that the buildings are quite always never, they're never 100% occupied, and based on some literature studies, we could put this kind of people distribution. That means that the average value of the occupancy hours is about 63% from 8 a.m. till 7 p.m. And this is how we consider the load distribution for the other gains, which are the lighting, the PCs, and some other electric gains. Here you may see some pre-analysis on the radiation, solar radiation on the east basin. So we consider the effect of the building on the east basin in front of the considered building. This is how the building behaves in terms of the diffuse solar radiation, and so that means that it's around about 1/3 of the solar radiation you might have. And this is the strong effect of the direct solar radiation. As you may see, this is the direct solar radiation in June. So we are in London, so there are some very cloudy days, so not silence here. But you can see that there is almost no direct solar radiation. So in red, there is a direct radiation entering in the, or impinging the east surface. The second step was to how to model the double skin facade. Of course, there are two possibilities. One possibility is to make the tool. In this case, we used Transys as simulation software, dynamic software. The first possibility is to make everything inside the software, but then you really don't know what happens. So you don't know exactly how the software can model the solar radiation. So we could I prefer to make my own calculation model for the greenhouse space, and this is how was the effect of the solar radiation. So at the end, we came out to this profile of heating and cooling. The HVAC system in this case is always right. So in this case, they prefer to have 7 days a week, 24 hours a day, running the system, heating and cooling, all parts. So they want to maintain these conditions. While the ventilation system, which is around about 5,000 cubic meters per hour, is running only during occupancy hour. So this is the Franco units loads, and this is the air handling unit loads, and the summertime. So this is the overall heating and cooling gain, which are faced by the boiler system in this case and the fuel system. And then there is another problem. How can we compare the simulation with the measurements? So so we have the gas boiler values month by month, and the electrical bills for the chillers. And of course, the bills we had, they were from 2011, while we used the best reference here, all London, and of course there are differences in the two climates. So you have to consider these differences. We prefer to use the best reference here because the weather data we have, they were really not that good as to carry out an energy simulation. So we have really no time to look at the detail on the connected data. So what we did, based on the external average temperature, we calculated or we estimated the EDR of the monthly EDR of the chiller machines, and based on that and based on the electricity for the chillers, we estimated the cooling load of the buildings. And this is the comparison on the right, on the left side is the comparison between the measured values, or let's say the estimated values from the measurements, which is blue, and the red is the model. But of course, the outside temperatures were different, so we had to consider some degree days for cooling So we had to make some arrangement considering the different temperatures, outside temperatures. So we considered the duty day in cooling, and at the end we came out with this difference between the simulations and the measurements. And then for considering the efficiency of the systems in terms of terminal units and distribution and control, then we based our evaluation on some standardized values we have for heating and cooling in our national standards, which are very similar to the European standards, 15316, EN 15316. And based on that, we estimated an average value of, for the cooling system of 86% from distribution to emission, which was round about the ratio between the simulated values and the measured values. So we have a very good thinking of the data in this case. The same procedure we made it on heating. In this case, we had directly the wheels, the natural gas wheel, and then it was the floor power and the energy. And again, we passed through the degree day for heating. And in this case, the overall efficiency of considering also the gas boilers, the estimated value was 60%. And the ratio between the calculated and the measured value was 55%. So it was 5% difference in the two cases, which was quite good. So we decided that the simulation was good enough, and then we went through the next step, which was considering 5 different other retrofit of the HVAC system. The first 2 are related to the air handling units. One, in case of without post heating, there is no post heating here, and that was mainly for economical reasons, because they should have post heating with the gas boiler. So that means that meant in the past a lot of energy and cost. But of course, they couldn't really keep the relative humidity inside a certain range. So if you want to keep the relative humidity, then you have to really cool, especially during summertime, the air and then mostly the air. So we did both the investigation. Then the third case was the case of heat recovery heat pumps. Heat pumps, the heat recovery means that you can, at the same time, on the condenser, you can release heat, and on the evaporator, you can cool the system. So that means that you are a system where you only are consuming electricity, and you have double effect heating and cooling. And of course, this is possible when you have contemporary heating and cooling loads. Then we had the combination of the heat recovery heat pump with the 2 air handling units, without and with post heating. So here is the presentation of the energy demand of the buildings, and in the orange area is the recovery heat. This is with a new heat recovery unit, with an improved heat recovery unit on the air handling unit, without and with post heating. So you can see here the effect of post heating. There is the red area used for post heating energy. And here is the case of the heat pump, where we also estimated the so-called total energy ratio, which is the heating and cooling power divided by the absolute, the absorbed electrical power. It's a sort of general CFD of the system, which is always quite high. And then the combination of the air handling unit and the recover, the heat pump. Here you may see that for the post heating, you always recover the whole heat. So it's the post heating is for free. You will have to condense a little bit higher compared to the outside temperature. In any case, you can recover the whole heat for the possible. You can really control better the relative humidity inside the building. And then we consider the primary energy consumptions and the CO2 emissions in the different phases. In the left, on the left side of the diagrams, there is the baseline, and here you may see the effect of the possibility to use the air handling units in the second and third case, and the heat pump in the heat recovery units, without and with the air handling units. Another interesting aspect is to look forward, so to look at the future. In Europe, and especially in the UK in this case, there will be an increasing use of renewable energy for producing electricity. Especially in the UK, there will be a lot of investment on offshore wind turbines. And that means that the electricity will be more and more produced via green energy. And if you replace the existing boilers with heat pumps, that will allow to have reductions of the CO2 emissions. So we consider these two types, green path, slow progression in green and dark green, which are based on a national, on a British publication of the ministry. And in this case, we could see that we could go to 2020 and 2025 because the order should be the same this time. And of course here you may see what kind of effect you might have in terms of CO2 emissions in 2020 and 2025. And it doesn't matter if there will be more or higher or lower amount of green energies for the electricity, but there will be a strong reduction on the CO2 emissions if you move from boilers to heat pumps. So moving from boiler to heat pumps in 2025 means a reduction of CO2 between 80 and 90% depending on the mix, energy mix of the electricity in Great Britain. And then we made some cost analysis. And we consider the extra cost between the proposed solutions and the standard solutions for replacement of the HVAC system. And here is the economical evaluations have been carried out with a simple payback time, which was in the case of the use of the heat pump and the air handling units within 2 or 3 years. And also some more detailed cost analysis based on the increasing costs for electricity, gas, and the discount rate based on the last 11 years in Great Britain. And at the end, there were very interesting results in worst case and best case. So in both cases, we had really very interesting results when you consider 15 years as net present value. So the work which is ongoing is to consider this building like in other locations. The locations will be Istanbul, Paris, Berlin, Shanghai, and Johannesburg. And we started with Istanbul. I have only some preliminary results. So we investigated the same building, so very well insulated building, with the same glazing elements. So we didn't change the solar factor. So of course, in this case, the cooling load is much higher than the heating load, and in this case there is no heat, not heating on the air unit. So this is the overall amount of energy demand. So even here, it is quite interesting because when replacing a heat pump, so based on this first chart, even when you replace the heat pump, the existing system still have a high efficiency, which is around about from 10 to 20% in Istanbul. But of course, this work is under progress and further results will be given in the future. So coming to the conclusions, the heat pumps, they may achieve really good results in terms of costs and emissions of CO2. And if there will be an increase, and there will be an increase in the production of green energy in the electricity grid, this will lead to further reductions of the CO2 and replacing existing boilers with heat pumps. And if you have some questions, you can go to the, I can ask Mr. Titura some more details on the. I'm here for any question. Thank you.
Thank you, Dr. Riccardi, and I think it was.
I think it was quite an interesting presentation, especially when it comes to economics of the proposed retrofit and its innovation, because we all understand that without putting a face to the research, it will not fly. So now we have 10 minutes of discussions, questions, comments, before we proceed to the next session.
I have a question, but maybe can we go back to the with and without, please? That we showed two curves, yeah. The next one, please, yeah. The TER for with and without, why is it staying the same? Or as you said, it's 4 and
This one,
yes.
Without and with.
Yes.
Yeah. Well, it's not. Yeah, good question. It's not really this. It's not really the same. They are very similar. It's quite the same. There is a small. Well, there is an increase if you are doing without.
Yeah.
No, sorry, with. Because you are recovering the heat, which is for the cost. Not that much. I mean, it's not that high. I mean, the big amount of that energy is anyway. So if you compare demand for the post heating compared to the cooling load, it's much higher than cooling load. But that's because you are considering only almost the net energy of the heating. Of course, if you are using the boilers and you have so partial load of boilers, then the efficiency of the boilers will decrease strongly. So you have double of the consumption.
Any other question, comments? Excuse me.
Mike.
I just want to ask about the conclusion that said that it would be our best choice to have the heat pump because the electricity sources, we are consuming electricity, and electricity sources, they will be moving towards more renewable sources. In many countries in the Gulf and in Lebanon, the sources of electricity is still fuel, and the municipal source of electricity is probably the worst polluting power source, more than boilers and more than generators, local generators. Would it be wise to depend on this source of electricity if it continues to be dependent on oil and not renewable sources?
That's a good question. You should consider the overall efficiency. Okay. You should consider the overall efficiency of your electricity grid compared to the seasonal COP of the machine. Because of course you have less green energy when you are producing electricity, but you have higher temperatures in winter time. So the COP of your machine should be maybe 4 if you're using an air-to-water heat pump. So still, you might have a not really efficient system for producing electricity. But if you make the comparison in terms of primary energy, could be that you might have anyway an improvement in using the heat pump. I cannot answer you. What I can say for instance, in Italy, the level, the seasonal COP level, where you have a more efficient heat pump compared to a boiler, considering 100% the efficiency of the boiler, okay, it's 2.2. So that means that if you have a seasonal COP which is higher than this, then you are saving primary energy. And of course, the emissions are located in some areas where you are producing electricity, where you can control better the emissions rather than having different chimneys around the city. So it depends. I would say that if you have more than 3 or 3.5 as a COP, a seasonal level, I think that you should, even if you have not so much high amount of green solutions for the electricity, still, in terms of primary energy, you have a benefit if you're using a heat pump compared to a
Any more comments, questions?
Here in the city, sorry, last one. Yeah, here in the city, financial, I guess just
this one.
yes.
Yeah, here you have not so high. I mean, you have, in this case, you are using the boilers. So yes, you're using the boiler for providing the most heat. So you have almost no benefit in terms, but you have a most heat. So you're improving the environmental quality.
I see.
While otherwise you have a benefit on also on the environmental.
Thank you.
Thank you, Dr. Picante. Once more. I will stop using this. Okay. We were supposed to have the second presentation from Mr. Hussam Shibaw, but apparently he will be a bit late. So we will start with this third presentation, which was planned to be third presentation today. It's going to be presented by Mr. Muhammad Haj Hassan. He's from Khatib al-Alami Enterprise, and he's going to be doing a presentation on integrated water, cooled VRV systems, and underfloor heating. Engineer Muhammad Haj Hassan is a project design engineer at Khatib al-Alami company, and he's an EUB graduate with a mechanical engineering degree and master's degree in financial engineering. Holding 8 years experience in design of HVAC, plumbing, and water systems and for different types of facilities, and member and board of governance member to the ASHE Lebanese chapter. Mr. Mohammed Haj Hassan, please, floor is yours.
Good afternoon, everyone. The topic of today is integrated water cooled VRVs and underfloor heating system.
This mic is working.
It's working?
Yeah.
Okay, can you use it?
I switched off the
Does not have.
No? Can you hear? Yes. The topic of the presentation is integrated water cooled VRV and underfloor heating system. The concept of this integrated system first surfaced when I was designing a residential project here in Lebanon. It's called Beirut. As usual, we start by evaluating the needs of the different stakeholders in order to come up with a suitable system. In our case, it was VRV for the cooling and underfloor heating system. Then we studied the possibility of trying to integrate both of these systems. So we started by developing an operational configuration, all the way leading to a complete design. These are the points that we are going to discuss throughout the presentation. Evaluating the needs. The developer is always concerned with cost, the tenant's comfort, and the architect with aesthetics. Many mechanical engineers here know the challenging constraint of an architect. This is an essential project I was talking about. It's called Beirut Terraces. It's a 25-story building, high-rise building, located near Phoenicia Hotel. It's currently under construction. It has 131 apartments, which means the tenants are concerned with privacy and individual system control. As you can see, it's multi-layered stratified structure with 4 different exposures and a glazed elevation. This means we have diverse heating loads. The architect provided us with a limited roof space and no technical resort. His main concern, he didn't want to see any kind of air conditioning unit or VRV unit on the terraces. He wanted it clear. Starting with the system design. Whenever we have buildings with diverse loads, we have to think of an energy recovering water loop to transfer energy from one place to another. Extreme pipe lengths causes capacity reduction. So the option was to go for a VRV system floor by floor. As for the large glazed areas, we had no place to put a traditional radiator, so we selected an underfloor heating system. Starting with the water-cooled VRV. Honestly, I didn't know what the water-cooled VRV was before I started this project. We usually work with an air-cooled VRV. VRV or VIF stands for a variable refrigerant volume or variable refrigerant flow. It's similar to a mini-split unit. However, the VRV unit is connected to multiple indoor units, and it uses refrigerant as both cooling and heating medium. However, the tenant can control the amount of refrigerant flow at the evaporator. The refrigerant is not circulated to multiple indoor units. The difference with water-cooled VRV is you can cool it using conditioned water at temperatures ranging between 15 to 45 degrees. You have this building. We took from the architect a utility room and replaced the water-cooled VRV inside the apartment. So there's nothing exposed on the elevation or outside. As for the underfloor heating system, heating is uniform. The floor is uniformly heated by heated pipes. System takes up no wall space, and the system runs at much lower temperatures. Supply temperature of 45 and return temperature of 38. The return temperature, or this delta T here, we can use it to operate the VRV for cooling or heating as a heat pump. This is what we're going to discuss. This is a schematic configuration. As you see, we have each tenant has a VRV and an underfloor heating system. This is the water loop. This is the water loop we're going to use. We're connecting it to a cooling tower and a boiler. During cooling operation, T1 are the temperature sensors and V are the motorized three-way valves. When T1 exceeds a certain preset temperature, for example 30 degrees, what will happen is V1 will open and V2 will close, and the water will circulate through the cooling tower and condition the VRV. Heat dissipated by the VRV can be easily used to heat the hot water bottles. In the heating operation mode, the underfloor heating is requiring hot water temperature. What happens, T2 will drop below a certain preset temperature, let's say 45 degrees. V1 will open, V1 will close, and V2 will open, and the water will be circulated through the water. And then here in this scenario, the VRVs can operate in the cooling or heating mode as a heat pump, because we have a low return temperature. In the recovery operation, let's say during moderate climate conditions, some people with the southwest exposure will require cooling and the others will require cooling. What will happen here, T1 and T2 will be set between a range of temperature, between 40 to 45 degrees. Both V1 and V2 will close, and heat dissipated, heat loss from the underfloor heating will be gained by VRV. self-sustaining system. This is the operational configuration. We place a cooling tower on the roof and a boiler in the basement. The cooling tower is connected to a plate heat exchanger because we need the loop to circulate all over. Each apartment has 2 heat exchangers, one connected to the VRV and the other connected to the floor heating system. This is the system component of a cooling tower. You have a cooling tower using evaporative cooling. Let's say the outdoor temperature is 35 degrees. It will supply us with a conditioned water of around 29 degrees Celsius. This is the primary circuit. It has a condenser pump connected to the plate heat exchanger. After the plate heat exchanger, the secondary circuit or the cooling or heating circuit. Whenever T1 exceeds 30 degrees, the two-way valve here will open and the cooling tower will operate. And the same goes for the boiler. We have a primary circuit, we have a secondary circuit with a secondary heating and cooling pumps. The boiler supplies temperature at around 80 degrees, but it requires 45 degrees for underfloor heating. However, 80 degrees is needed to heat not just basic heating, but also the hot water bottles. This is a component inside the apartments. We have a plate heat exchanger, which is used to break both pressure and temperature. We have a two-way motorized valve which belongs to secondary VRV pumps. This is what I was talking about. The tempered water at 38 falls within the operating range of the VRV, which is between 15 to 45 degrees. This is the operational configuration. During cooling, T1 is set at about 30 degrees. What will happen when T1 exceeds 30 degrees, V1 and V3 will open, V2 will close, and V4 and V6 will close and V5 will open. The circulating pump will circulate the water through the VRV. During the heating operation, V1 and V3 will close, V2 will open, and the water will circulate to the boiler to the underfloor heating system. Heating and cooling operation mode. We have T1 is at 40 degrees, T2 is at 45, and the loop will circulate through both heat exchangers. So whenever the temperature, let's say the system requires cooling, the cooling tower will operate. When the system requires heating, the boiler will operate. You can easily add a solar energy loop if you have space for solar panels and connect it to the loop or a geothermal system. And this is a complete design. We have 131 apartments, and this is a roof plan. Okay, thank you. Any questions?
Thank you, Muhammad. I think it's quite interesting. And thank you as well for taking this at the time. So I have a couple of questions, but I will leave the floor first for the audience to yes, question.
Can I ask a non-technical question?
Yes.
2 questions actually. How much is the apartment?
That's a very nice view. Actually, I'm sorry. We need to talk to the developer. He can make a good price.
Just a comment. It's no, really a real question now. The VRV that logo that you have now.
The VRV. I did it.
You did that?
Yeah, I did it for the presentation.
Because Ashley was asking, what is this? Is it a commercialization thing? And is it
actually, my wife, she's an architect.
Yeah.
She insisted on
this is very nice. We like it very much. Thank you.
Yes, please.
The system that you have a common boiler and a common cooling tower.
So it is reversely determined.
Okay, so the entire building, as far as common services, they should have the boiler and the cooling tower as common.
The system is the water-cooled VRV after the plate heat exchanger. The tenant can operate it whenever he wants. However, we need this general services to condition or heat the water. But it's needed. Yeah. We can have BTU meters and we can.
Do you have the BTU meters?
Yeah, of course.
Yes.
Why are you using so high temperatures for the boilers?
Yeah, because I needed to keep the space heating and the hot water bottles. You need a temperature in the hot water bottle of around 60 to 70 degrees. You need a high temperature. Else you can use a condenser boiler, gas boiler, to supply 45 degrees.
What would be the cost comparison between your system and the conventional chiller system?
I did a cost comparison, but I didn't put it here between a water-cooled VRV system and a water-cooled chiller system. It was actually the same. However, because most contractors here don't know how to install water-cooled VRV, and not many people use it. The contractors here in Lebanon, the cost is about 1.2 or 1.3. But technically, it should be the same, and the running costs are much lower on VRV.
So they pay back approximately?
I don't know how. I didn't start on this one.
Okay, and related topic, did you do any assessment on the types of differences in the automation and operation of the system compared to the convention?
No, I didn't comment.
What is the refrigerant?
We didn't hear Any other questions? Comments? Well, I'm happy to see and to know this type of administration. We have been here. You're not that young, but you're younger than your guys. Thank you so much for the weekend. Apparently, we are still missing Mr. Hussein Shibari. He came? Okay. I've got 2 minutes.
Attending